In this video, I'm going to show you what is a differential equation, what is the order of a differential equation, what it means that a function is a solution to a differential equation, and how we can check if a function is a solution to a differential equation. In algebra, we have seen equations like this: x squared equals 9. In this equation, x is the unknown, and x is a number that we want to find that number. X is a number that when we raise that number to the power of 2, it equals 9. And we know that the solution of this simple equation are positive and negative 3. These are the two numbers that satisfy this equation. But in differential equations, the unknowns are functions. But what is a differential equation? A differential equation is a relation between an unknown function and its derivatives. For example, y prime equals y double prime plus 2y prime minus 3y equals x plus 5. Y prime equals 1 over x minus y. These are examples of differential equations. In this simple differential equation, y is the unknown function, and that function has this property that derivative of that function, y prime means derivative of a function, y prime derivative of that function equals to the same function. In this second example, y again is the unknown function, and it has this property that second derivative of that function plus 2 times derivative of that function minus 3 times the function equals to x plus 5. For this simple differential equation, let's see if we can guess the solution to this differential equation. Here we are looking for a function that derivative of that function equals to the same function. So we have to try to guess a function that derivative of that function equals to itself. What was the function that derivative equals to itself? If you remember from calculus, the function that derivative of that function equals to itself is e to the x. Remember, derivative of e to the x is e to the x. So this is a solution for this differential equation. What actually, if you think about this differential equation, this function is also a solution to that differential equation, 2 times e to the x, because if we take derivative of 2 times e to the x, 2 is coefficient and derivative of e to the x is e to the x. So as you can see here, derivative of this function equals to itself. So this is another solution for this differential equation. And similarly, in general, y equals c times e to the x, which c here is a constant, is the general solution of this differential equation, because if we take derivative of this function, c is a constant and derivative of e to the x is e to the x. So this is a solution for this differential equation. If in this general solution we put c equal 1, we get this solution. If we put c equals 2, we can get this solution, and so on. So we say this is the general solution for this differential equation. Here we guess these answers for this differential equation. Later we will learn how we can find the solution of differential equations. Now that we are a bit familiar with differential equations, let's talk about the order of a differential equation. The order of a differential equation is the order of the highest derivative that appears in that equation. For example, in this differential equation, the highest order of derivative is y prime, and so we say this differential equation is the first order differential equation. In the second example, the highest order of derivative that appears in this equation is y double prime, and so we say this is a second order differential equation. And in this third example, because y prime is the highest order, again we say this is a first order differential equation. Now look at this differential equation. X, y triple prime plus x 4y double prime minus 4y equals to cosine of 5x. What is the order of this differential equation? This equation is a third order differential equation because y triple prime is the highest order of derivative that appears in this differential equation. Now let's see what it means that a function is a solution to a given differential equation. For example, here this differential equation is given and we want to check if this function is a solution for this differential equation. We can check to see if this function is a solution for this differential equation by substitution. If y equals 5e to the negative 4x, y prime, because here we have y prime, first let's find y prime. To find derivative of this function, we have to write 5 and we have to take derivative of this function. Derivative of e to the negative 4x is e to the negative 4x times negative 4. Remember, derivative of e to something in general is e to the same thing times by derivative of that expression, derivative of the exponent. So derivative of e to the negative 4x is e to the negative 4x, the same function, times by derivative of the exponent. And derivative of negative 4x is negative 4. So y prime is 5 times e to the negative 4x times negative 4, which equals to negative 20 e to the negative 4x. Now if we substitute this for y prime here and this expression for y, it should equals to 0. Otherwise, this is not a solution. Y prime is negative 20 e to the negative 4x plus 4 times y. If we multiply 4 in this expression, we get 20 e to the negative 4x. Negative 20 e to the negative 4x plus 20 e to the negative 4x equals 0. And this shows that this function is a solution for this differential equation. Before I show you another example, I should mention this, that the general solution for this differential equation is c e to the negative 4x. And later we will see how we can find this general solution for this differential equation. And this given solution here is a special solution for this given differential equation. Note that here, if you plug in 5 for c, you can get this special solution. Now look at this differential equation. Y double prime plus 9y equals 0. And here we want to verify to see if this function is a solution for this given differential equation. Y is given a sine of 3x plus b cosine 3x. We want to see if this is a solution for this differential equation or not. First, we have to find y prime and then y double prime, because here we have second derivative and this is actually a second order differential equation. Y prime, derivative of this function, is 3a cosine 3x minus 3b sine of 3x. Let me here remind you that derivative of sine of some expression equals cosine of that expression times by derivative of inside because of chain rule. So derivative of sine of 3x, as we had here, is cosine of 3x times derivative of inside, which is 3. So derivative of sine of 3x is 3 cosine of 3x. And because a is a coefficient, we just write the coefficient. We are not touching the coefficient. We are writing the coefficient and we are taking derivative of the function. And derivative of cosine of some function is negative sine of the same thing times by, again, derivative of inside. So derivative of cosine of 3x is negative sine of 3x times by derivative of inside function, which is 3. Second derivative, y double prime, equals to, if again we take derivative of cosine is negative sine, and don't forget to multiply by derivative of inside, and derivative of inside is 3. If we multiply that 3 by this 3, we get 9. So we have negative 9a sine of 3x minus derivative of sine of 3x is 3 cosine of 3x. If we multiply that 3 by this, finally derivative is negative 9b cosine of 3x. Now if we plug in this expression for y double prime here, we get negative 9a sine of 3x minus 9b cosine of 3x plus 9 times y. The y is this function, a sine of 3x plus b cosine of 3x. We have to check to see if this equals to 0 or not. Note that negative 9a sine of 3x plus 9a sine of 3x equals 0. And negative 9b cosine of 3x plus, if you multiply this 9 here, we have 9b cosine of 3x. They cancel each other also. So this expression equals 0. And this shows that this is a solution for this differential equation. Now let me show you another example. This differential equation is given y prime plus 2x y squared equals 0. And we are given this function as a solution for that differential equation. We want to verify if this function is a solution for this differential equation. First, as usual, we have to find y prime. Note that this is a first order differential equation because the highest derivative that appears in this differential equation is y prime, so this is a first order differential equation. For finding y prime derivative of this function, we have to use quotient rule. First, we have to find derivative of the top, which is 0, times by bottom is 0, minus, we are writing the top function and we have to multiply by derivative of the bottom function, which is 2x, all over the bottom function squared. If we simplify this, we have in numerator negative 2x, and in denominator we have 1 plus x squared squared. Now, if we substitute negative 2x over 1 plus x squared squared for y prime here, negative 2x over 1 plus x squared squared plus 2x times by y squared. Y is this function. 1 over 1 plus x squared squared. If we write this again, we have negative 2x over 1 plus x squared squared plus 2x times 1 squared is 1 over 1 plus x squared squared. Note that this power 2 is for 1, which 1 to the 2 is again 1, and the denominator squared is 1 plus x squared squared. Now note that if we multiply this 2x in numerator, we get to this expression, negative 2x again over 1 plus x squared squared plus 2x over 1 plus x squared squared. Because the denominators are the same, if we add the numerators, they cancel each other. Negative 2x plus 2x is 0. So this shows that this equals to 0. And so this function is a solution for this differential equation. Example. Find the value for m such that the function y equals e to the mx be a solution for this given differential equation. Y double prime plus 2y prime minus 3y equals 0. So we want to find a value for m such that this function be a solution for this given differential equation. First, we have to find y prime and y double prime. Y prime, derivative of e to the mx, is e to the mx times derivative of mx, which is m. And y double prime is, note that here m is a coefficient. You don't need to do product rule for finding the derivative of this function. M is a constant, so just write the constant and take derivative of e to the mx again. Derivative of e to the mx is again e to the mx times derivative of mx, which is m. And if you multiply that m with this m here, so y double prime is e to the mx times m squared. Now if we substitute this for y double prime and this for y prime in the given differential equation, we have m squared e to the mx plus 2 times y prime, 2 times this expression, 2 times m e to the mx minus 3y, which is minus 3 e to the mx equals 0. For solving this equation, note that this is a normal equation as we had in algebra. For solving this equation, note that e to the mx is common between these terms, so we can factor e to the mx. And then we have ms squared plus 2m minus 3 equals 0. Now, note that because this times by this equals 0, we have to set each of these expressions separately equals 0. But note that e to the mx is never equals 0. Let me show you the graph of e to the x. This is the graph of e to the x, if you remember. And as you can see in this graph, e to the x is never equals 0. And so e to the mx cannot be equal 0. Always keep it in your head. E to any expression, it doesn't matter if it is mx, x, 2x, negative x, x squared, whatever. E to any power, e to any function, e to any function like f of x is always greater than 0. And it cannot be equal to 0. So here we only need to set the bracket equals 0. ms squared plus 2m minus 3 equals 0. This is a simple quadratic equation. If we factor this, we can write this as m minus 3 times m plus 3 times m minus 1 equals 0. Note that 3 times negative 1 is negative 3. 3 plus negative 1 is 2. Also, you can solve this quadratic equation by quadratic formula. So from here, m is negative 3 and m is 1. So the values of m that makes this function a solution for this differential equation are negative 3 and 1. I hope by watching this video, now you are a bit familiar with differential equations. To learn how to solve the differential equations, the different techniques for solving differential equations, watch my other videos. If you like this video, please subscribe in my channel. See you in the next videos.